Hello. Welcome to the Android track at GDD Brazil from 2010. My name is Tim Bray. I'm a developer advocate in the Android group at Google. Yesterday, I came to Brazil for the first time. I've never been here before. I found that it's actually quite difficult for a Canadian to get a Brazil visa, but on the other hand, they gave me a 5-year visa, so it should be easy for me to come back. Today is more or less the introductory session to the Android track. What Android is, how it looks to a programmer, why it's interesting, and what directions we're taking it. So I'm going to spend a certain amount of time talking to this slide. Let me see, is it big enough? Can the people at the back see it? Yeah, okay, good. So I'm going to spend some time talking about this because there's a lot of material on it. So Android is not a specification. It's not a standard. It's a great big chunk of software. There's no separate definition. This Android software is the definition of Android. And so here's what's in that Android software. Essentially, it's a reasonably current Linux computer system underneath with the Linux kernel, but without a huge amount of the other stuff that goes into Linux. A lot of libraries, the utilities, and the subsystems, and the user interfaces, and X windows, and all that stuff is just gone. It's a pretty naked kernel. And then on top of that, the next really big piece that we add is Dalvik. Dalvik is the virtual machine that runs most of the Android application code. It's a non-Java VM. It's architecturally very, very different from a Java VM. And it's optimized to run programs on mobile devices. It runs its own bytecodes, which we call DEX bytecodes, after the program that generates them. The next big piece is the Android application framework. And if you're going to write an Android application, you really have to go through the Android app framework. There's no other way to do it. Now, the framework itself runs on the native machine, and the Android app framework contains both a lot of code that runs on the virtual machine and code that just runs natively. And we'll talk about some of that in detail. It's quite possible for Dalvik code and native code to call each other. That's done using the JNI protocol that was developed in the Java community. And you can go both ways. Java code can call native code, and you can have native code that calls into a Java application, into the code that runs on Dalvik. Some apps have a lot of native code in them as well. This is almost entirely games. Most commercial and straightforward apps run entirely on Dalvik, but you can have apps that have native code. I think that's all the important. Oh, of course, then also inside Android is also the Harmony libraries. This is the library that was produced by the Apache project to be a replacement for the Java SE libraries. Now, it's not the complete set of Harmony libraries because Swing and AWT and Corba and lots of other pieces that aren't interesting in a phone are not there. So it's a substantial subset of the Harmony libraries. So those are the big pieces that go into Android. Now, probably the biggest single piece isn't the Dalvik, it's the Harmony, it's the Android application framework. So let's look at and see what you find inside the application framework when you look. So the green boxes are things that run mostly on Dalvik, written in Java, and the brown ones are things that are substantially written in C and run in native code, although they may have a Dalvik API to them. So a lot of them are just things that manage pieces of the Android application framework. So there's an activity manager and a window manager and a view systems, and those are the things that collectively take care of the screen of an Android device, what's being displayed on the screen of an Android device, and how you interact with it, and things like that. There's content providers, which is database interface. There's a package manager that takes care of actually running applications. Hey, it's a telephone. There's a telephony manager so that you can make phone calls and do SMS and things like that. There's a resource manager for taking care of all the binaries, the audio, the video, the
that kind of stuff. Location, every Android device has a GPS in it and a location subsystem, so there's a lot of code in there to take care of that. There's a thing for taking care of your notifications. These are just some of the big pieces. One of those things has ... to say that there are lots of other pieces in it. Over on the native code side, there's a reasonably large subset of OpenGL ES there, mostly for use by game designers, for people who really want to do immersive, animated things. SGL and Surface Manager are related to that. There's FreeType, so there's a fairly complete font handling subsystem in there. Every Android device includes the SQLite Database Manager. Fairly early on in my relationship with Android, I found myself, set up with a debugger, typing SQL code into my phone, and this was not exactly the future that I had imagined. But there's a media framework, once again, for doing low-level media stuff. There's a big chunk of libc, secure sockets layer. The point I'm trying to make is that Android's big. I mean, it's really a very, very large, comprehensive software suite. It wasn't built in a day. They've been working on Android for years. Many of the people who built Android had previously worked at Danger and had previously worked at B. So for a lot of them, it's sort of their third go-around to building an operating system. So it represents the culmination of a huge amount of experience. So at the end of the day, as a developer, what we produce are applications. So if you look inside an Android application, which is an APK file, there's really three things. The Android manifest is the part that represents the bridge between an Android app and the rest of the system. And it contains all the things the system needs to know in order to run the app, like what permissions it requires, what hardware it accesses, what the various pieces of the application are. Then you have the actual Dalvik classes, the DEX bytecodes that actually make up the logic of the application. And you have a bundle of resources. These would be things like the strings and the audio files, the video files, the images, whatever you want. So by and large, today, these things are produced in Java. And as a result, they're actually written with Java, although it's not Java at runtime. And as a result, we get to inherit a large part of the Java toolchain. And the tooling for doing this stuff is excellent. There's a first-rate plugin for Eclipse. There are also somewhat lesser evolved plugins for NetBeans and IntelliJ. There are debuggers and monitors and profilers and all the different pieces that you would typically expect in a modern software development chain. It's not an official Google project, but I'm happy to report that for those people who don't like Java so much, there is work in progress to make Python and Ruby and Scala all first-class citizens so that you can program Android in a variety of different languages. So this is the mainstream of Android application development that probably most of you would end up seeing and working in. Now recently we're seeing a lot of apps that are what we call NDK apps as opposed to SDK apps. NDK stands for Native Development Toolkit, and basically they're just the same inside, except they also contain some binary libraries and JNI, the glue that you need to connect back and forth between the Dalvik stuff and the native stuff. These are basically used by game programmers and only by game programmers. Now, from our point of view in the Android group, we're not 100% convinced that you really need to use C to write a game. There are some actually quite high-performance games on Android that run 100% on Dalvik. They were written in Java. They work just fine. But a lot of game designers, they don't even want to hear you talk about that. As soon as you say Java, they go, I can't do that. These guys want to live entirely in C and C++. Now, if you're going to do this, the tools aren't as sophisticated. You don't get the nice IDE. You don't get a lot of the tools. You have to, have your own Ant-based build system and so on. But, game developers are tough anyhow. They're used to pain. So they do okay with this. So how many of you are already Android developers? How many people have Oh, excellent. So less than half. So good. So this talk will still be valuable to you. So suppose you want to become an Android developer. Here's what you have to do. And let me start this by telling you my own personal Android story. I've always wanted to program phones, but I'm a very strong believer in open source and non-proprietary approaches. And so when Android was announced in 2008, I was very interested in it. So I went and I bought one of the first Android phones, the G1, and I got it in 2008, the day before Christmas vacation. So I was going off to spend Christmas with my mother. And so I got my new phone, and I took a resolution that I was going to write my first application by New Year's Day. So in about 2 weeks. And I made I succeeded in doing that by about 4 hours. And it was astounding to me how easy it is for somebody who is already a Java or C# programmer to learn Android. This is one of the biggest advantages to Android, is it's very, very easy to pick up. So how many people in the room are already programmers in Java and C#? Okay, you can all be Android developers by tomorrow. I'm serious. There's really nothing to it. So what do? So here, the steps are all here. Let me see. Are there any of them not obvious? You just go to developer.android.com. You get it. For most people would prefer to use the Eclipse plugin, although some people prefer to use VI and Emacs. There's lots of tools in there to help you debug and profile and so on and so forth. One thing that a lot of people don't do, and they should, Android is open source, and you should use it.
Use the source, Luke.
You should definitely go and get the Android source code and download it. And here's why. Because the documentation for Android is pretty good, but no software documentation is ever complete. So sometimes you're looking at some API and you can't figure out, well, how do I use this location provider? It doesn't seem clear to me. So don't guess. Just go into the source code, because the source code for the operating system and the source code for all the Google apps is there. Well, all except one or two. Most of the Google apps is there, and you can go and see how other people use this. So don't guess, just copy. Absolutely use the source. And then it costs $25 to register as a developer, and then you've finished your application, then you go and you upload it into the Android market, and it's published. You're finished. There's no review step. The amount of time it takes to publish an Android application is just a few seconds. Now, that's nice, but it's especially nice when you've already published your application and you find an embarrassing bug, and you need to fix the bug. So, oops, so you fix the bug and you update it in the same day. No waiting. That's a really, really big advantage. So becoming an Android developer is very easy. So what I'm going to do now is I'm going to spend the next few minutes talking about the pieces of the system that a developer sees. So here's a list of the concepts that really define Android. Now, if you go and look at the suite of Android documentation, there's lots more stuff than you see here. But these are the parts that are really distinctive about Android, that make Android different from other approaches to writing software. And if you're going to ship something that's worth having, you're going to need this stuff. Okay? So let's dive into this and introduce the concepts that you're going to need to know to be an Android developer. So an activity is sort of the equivalent of a screen or a web page. It has some layouts where you show things on the screen. This is where you display text on the screen, where you display graphics, where you animate things. It's where you receive the events when somebody taps on the screen, when somebody shakes the phone, when you move location. It's where you play movies. It's where you record audio. It's where you play audio. All this stuff happens in activities. And each application has a main activity that is the first one to be started, and when you are finished with one screen, you move to the next screen to the next activity. Okay? So you move from activity to activity. So I have a couple of screenshots here that show Android activities. So it's a music player, and here, boy, the projector's kind of overloading the black. But so the first screen is the list of songs in the music player, and the next screen shows the music playing a song with you can vote it up, you can vote it down, you can pause it, and so on and so forth. So these are two activity screens. You launch from one to the other. Now, the life of an activity is a little bit complex, and that's because, remember, you're not in control. The user is in control. The user can start your activity at any time. The user can switch to a different program at any time without telling you, so you can be suddenly stopped. The operating system might destroy you because it's short of memory. Android apps, they're not like a program running on a web server where your program will, in principle, run forever until you stop or you have an error or something. In Android, you have to be prepared to be destroyed at any time, because if the system gets short of memory, your program is gone. Okay? So you have to be prepared to start and stop. There's a life cycle here that you have to learn and understand. And these are the names of the programs, the callbacks that get called. When your application is created, you get the onCreate callback. When it gets started for the first time, you get onStart and onResume called together, and then you're running. You are the front. You are in control of the screen. It's you and the user talking to each other. Now, it's possible that a pop-up comes up in front of you, something else in the system puts up a dialog, then that would come on pause, because it means that you're still, some of your material is still displayed, but you're not in control anymore. And then if they switch in another application, that's on stop, because you're in background now. You're gone. And then eventually the phone is shut down, or the system shuts you down, and that will be on destroy. So you have to have code to handle some or all of these. In the typical life of an application, you will be started, you will be in the front for a while, he will put you away, the user will be talking to somebody else, they'll bring you back, then it goes through on restart and so on and so forth. So what that means is that if your application has any state that you need to keep track of, you have to make sure that you save that state during the on pause or on stop, and make sure that you can bring it back when you're brought up. And it also means that people don't want to wait, so you have to be very fast about doing these things. So activities are sort of the meat of the Android user interface. Now, Android is just a Linux system. So you can do a fork at any point, create a new process. You can spin up threads anytime, and they will run in the background. But remember, the system can always just kill it when the system gets short of memory. And these devices, they really don't have very much memory. If the system gets short of memory, it'll just kill your process for you. But sometimes you need to run in the background, and you're doing some important or useful work for the user, and you really don't want to be killed. So for example, suppose you are playing music, okay? Or suppose you are tracking the user's location to keep a diary of where the user's been, something like that. So in that case, you want to be in the background, but you want to say to the system, please, please don't kill me. And for this purpose, you use a service. So a service is really a lot like an activity, but the system will try very hard to keep it alive. Now, sometimes the system will kill a service, but then it will make a big effort to bring it back again soon. If it has to kill it for a while, it will bring it back. So here we have some examples of services. So the first one shows the music player, the same one we were looking at before. So then you go to another application, and the music player runs as a service. And if you look at the notice bar, you can't really see it with this projector, up in the notice bar there where the red circle is, there's a little glyph saying, oh, by the way, there's a service running in the background. And that's one of the rules. If you are a service in the background doing useful work, you should really let the user know that you exist. So you should put a small notice in the notice bar. And if the user pulls down a task manager, or the notification bar, you can see that it will tell the user that the service is running. Services are very interesting. They're quite a bit less complex in their life cycle than an activity, because they don't have this issue of coming to background and forward so much. There's really only three methods that you really have to worry about: on create, on start, and on destroy. And most of the time you can assume that you're running. Typically, if you look at a typical Android device, there will always be a few services running. The system has some of its own, and there will be others running. Okay? So the vast majority of your application code will either go into an activity or a service. This slide is a little bit of an oversimplification. I've discovered when writing services that there's actually quite a lot of other bookkeeping code you have to do to set it up. It seems to me that it's a little bit more complex than it needs to be, but it's not too bad. Now, the next really important thing about Android is intents. And intents are one of the really new ideas in Android, and they're one of the things that make Android really unique. So, and intent is actually a fairly complex object. So when you want to start an activity or start a service, you always give it an intent as the argument. Okay? You say, go start an activity using this intent. So the intent has quite a few things in it. It has a target, which I'll talk about in a minute. It has an action. An action, there's a set of well-known actions in the system. Things like display and open and make a phone call and things like that. And it also has a MIME type, the same kind of MIME type that goes with a web page. So image/JPEG or text/HTML or something like that. And you can also have a category and some optional extra data. So suppose I want to start a service to move from the music list to the music player. So I use the target for that. So you give the service a target, which is basically your class, the class name. And you say, go start a new activity with this class name, or start a new service with this class name. And that's saying, I want you to run this very specific code for me. Okay? That's easy to understand. What's actually much more interesting is you can leave the target out, and you can just say, I want to launch a service to play this music, to open this web page, to what's some other things? I had some ideas in here. Open a web page, or to make a phone call. Here's a phone number. Call that number. So you can make an intent to do those things and just give it to the system and say, go start a service. And then the system will go and find the best match with what you said. And this can really produce some magic. So let me show you some of the magic this can produce. So here's a very common example of the kind of thing that happens with an Android user. So in the first screen you see is a Twitter client. So we're watching Twitter. And this is the tweet stream of Pat Chanizan, one of the guys who's speaking, maybe now, actually. So when he came to the airport yesterday, he lost his luggage. And he did a tweet yesterday about how I lost my luggage, and he did it with Foursquare. So there's a URL in the Twitter thing. So I tapped the URL, and the Twitter client just sent an intent saying, open the web page, and that opened up the browser on the Foursquare site, saying, here's Pat's thing. And on the browser window, there's a map. So you click the map, and you go to a map of Sao Paulo showing the airport. Okay? And this is done by intent. And the system keeps a stack of all the activities, and this is the reason that in Android, the back button works. Okay? So every time the user presses the back button, you just go back to the previous activity. This is something that a lot of other operating systems don't have, and it's an immense, huge benefit to the usability of Android. Okay? So that's one thing that you get for free from intents. Here's another one. In the first picture, this is the Gallery app, and it's showing a picture I took of some clouds. And if I tap on the Share button, a list of things pop up. And that is a list of all the things that are prepared to handle the data type image/JPEG. So you can query the system to say which applications are in the system that are able to handle image JPEG, and then you can create a list. Now the way this works is that an application can register what's called an intent filter. And an intent filter says, I can do the following actions on the following data types. And so there's also an API, so an application can go and see, which other applications are ready. So here's a sharing menu. And what that means is that anybody who is willing to handle image/JPEG can be put on the sharing menu for the Gallery application. So on Android, it's really, really, really easy to integrate different applications. And there's an important philosophical point here. I don't want to talk about that yet. Sorry. There's an important philosophical point here, which is that Google does not believe that one website should provide all the services for a user. And we don't believe that one application should provide all the services on the phone. So the Google website is famous for sending you away quickly. right? You come here, you find what you want, you go somewhere else. And our vision for the phone is having a bunch of applications that do a bunch of different things, and using intents are able to cooperate to provide the user with the maximally full experience. Okay? So intents. You really, really, really have to learn about intents and understand them well if you want to be an Android developer. Okay, the next piece of apparatus that you need to understand is a broadcast receiver. This is sort of like a service. It's when you need to be able to respond when something happens, but you don't need to be running. For example, you need to know if they plug in the headsets, or you need to know if the battery is low, or you need to know that the screen was dark but it was turned on. You don't need to be running. You just need to be notified. So you use this also an intent receiver. This is also done with intents. So you register an intent broadcast receiver with the system, and when this event happens, the system will deliver you an intent to your broadcast receiver, and you can do whatever is necessary. One special rule with broadcast receivers is they have to complete quickly. You're not allowed to take control of the phone. If you spend more than 5 seconds, the system will kill you. Okay, so maybe the right thing to do is to launch a service or something like that. Okay? But here's an example. This is actually a bad example. I realized today. This is an example of a music player, and he has a broadcast receiver for plugging in the headphones. Okay? So when you plug in the headphones, the music starts. Bad idea. The other side is good. When they unplug the headphones, the music should stop. Right? But that's the idea of how a broadcast receiver works. Very simple life cycle. You start, you run, you exit. You almost certainly won't be killed, and that's all there is to it. You get on receive, and away you go. Okay? Another important part of the Android system is content providers. So, as I said, the Android framework includes the SQLite 3 database, and if you go looking around the insides of an Android device, you'll probably discover that there are a lot of different databases, probably hundreds of different databases, and typically everything in the system, every serious data that you want to store on an Android is most often living in a SQLite database. Now you can use the database directly in your program. There are some database helper classes, so you can use it in your Java code or in your C code. But more often, it's designed to be wrapped around with a content provider. And once you've wrapped data in a content provider, then it is accessible to other applications. So that is how, for example, if you want to read the list of contacts out of the person's address book, or the list of songs out of the music application, or the list of phone calls that the person has made, or that kind of thing, those are all done by content providers. It's tremendously useful. Now, in theory, they say that a content provider can be used to wrap any kind of a data source. In practice, it seems that it's always SQLite inside a content provider, if you look. My personal opinion is that compared to the rest of Android, these are a little bit difficult and awkward and clumsy. They're not the nicest part of Android, but they have pretty high performance, and they work pretty fine. Using content providers is really quite easy. Writing a content provider I found actually to be quite difficult and tricky to get working. But they are tremendously useful. So, an obvious example, of course, is the music. The music inside is stored inside a content provider. And so you have a database, you have the content provider, and you can write a program easily to find all the music on a phone and play it. So almost certainly you'll have to use some content providers for any kind of a non-trivial Android application. One good practice that I'm going to mention now that is also going to come up in the talk on that's going to come up in the talk on performance is, I think there's probably a little bit too much use of SQLite. I think many people could just be very happy just storing their data in the file system, and they use the database because it's there. So it doesn't mean you have to use it. Okay, so threading is very central to Android apps. The threads on an Android system are just ordinary Linux threads, and the API looks is the java.lang.thread API. Now, the reason that you have to know about threads is that there's one special thread in every application, and that's the thread that owns the user interface. Okay? And it's very, very important that you shouldn't be doing network stuff or database stuff on the user interface thread, because it will be instantly noticed by the user that suddenly the phone will become slow. So really, to do any serious work in an Android app, you have to put it on a different thread. So that means you have to learn a little bit about threads and how to use them. We have a couple of nice helper routines to package up a thread to help you avoid some of the details. But I think that most Android programmers do eventually end up writing some threading code. I'm going to actually show you some code here from an application just to give you a feel for how it looks. In this code, here, I'll come over to this side for a change. In this code, it's reading some data out of a content provider, and it's writing it onto the disk using printline, and it's updating a progress bar. Okay, so the progress bar goes across the screen. Now, since the progress bar is part of the user interface, it has to be in the user interface thread. But the code that reads the content provider and does the printing cannot possibly be on the user interface thread because it might make the phone freeze. Okay? So the way it works is, first of all, we have a thing called a handler we create. I'll show you that in a minute. And then, so here's the main method of the activity, to onCreate. And so we make a progress bar. Okay? And then I make a new thread based on the copyIn class to do the actual reading and copying. So copyIn is a runnable. And so the calls variable there, that is a content provider. So one of the methods in content provider is move to next. So you just move to next to the content provider. And so we go and we move to next, and then we pull the current data out of calls with one of our own private routines I haven't showed you. We print it, and then we say scallProgress.setProgress. So we actually call a method on the progress bar to update itself. And that's a little tricky because that actually sends a message to the progress bar and it updates in the other thread, in the user interface thread. Now, when I originally wrote this code, I had a horrible race condition bug because of the different threads, and it took me a while to find it. And then finally, there's this thing called a handler, and a handler is a way of sending a message to another thread. And in this case, I'm going to use the handler to put a title on the page saying how many things I read and how many things I saved. So I give the handler a runnable and send that, and it will run on the UI thread. So you see a lot of this kind of code in Android. And in my experience, most of the actual tricky bugs and irritating problems that programmers have come from threading. Because threading has shared mutable state. It's got the potential for race conditions, for deadlocks. It's tricky. So watch out for that stuff. Okay, another piece of the system that I want to spend some time on is the Android manifest. So the Android manifest is an XML file that you have to create, and it is basically the declaration of the app to the system. And it names any special libraries, for example, the Google Maps library that you might want to use. It declares all the activities, the services. The intent filters are just there in the application manifest. They don't exist in your Java code. They're just right there in the XML. All that stuff is declared there. It's terribly important. It declares all the permissions. So when you install the application, it asks the person, this application needs these permissions. Is that okay? And if you try and use, for example, the telephone without having the telephone permission, your application will blow up. Okay? It also identifies the hardware that you need. For example, suppose you have an application that really needs a camera. You say, okay, I use the camera. Or it also declares which versions of Android this application can run on. And that's very important because that's used by Android Market. So the market looks at the manifest, and when the phone comes to look at applications in the market, the phone sends a message saying, hi, I'm a Milestone, I have these features, I run this version, I have a camera, I have no camera. And as a basis of this, the phone will not see any applications that he can't run. That's really important, because there are a lot of different Android devices, and there are more different kinds of Android devices coming all the time, and the Android manifest is how we make sure that nobody will ever see an app that they can't run. Okay? I could easily spend this whole talk talking about Android manifest, but I won't, because that would be boring. There's a bunch of other bits and pieces in the system. I mean, there's APIs for like the camera and the accelerometer and the GPS and all this stuff. Most of them are actually pretty easy to use. And the good thing is that you don't really have to learn how to use them because Android's open source, and because the world of Android developers is so big, just type GPS Android example into Google and go and steal somebody else's code. It's really the right way to do it. And all of our code at this level is Apache licensed. So we explicitly are saying, please, take this code, use it. The way that the screen is laid out, the screen layout is all done with some XML subsystem. There's a way to provide versions of your strings in all sorts of languages. There's utilities for inter-process communication, and there's lots more of this stuff in here. Okay, so I think those are really the big pieces of Android that you will be exposed to as a developer. Let me talk about where we stand with Android. This is a picture, it's so dark, of a building on the Google campus called number doesn't matter. It's a building on the Google campus, and most of the Android work is done inside this building. And when I'm at the headquarters, my office is right behind the green guy there. The releases of Android are named after desserts, and they come out in alphabetical order. So here you can see the history of the releases of Android, Cupcake, Donut, Eclair, Froyo. And I'm just going to play you a movie here that came on YouTube last week. Audio?
That's it.
He must have tranquilized him because I heard this dude was hard to catch up with. You gotta watch it.
These are the Android engineers, by the way. They all came out to do it.
She's gonna rotate.
You won't be able to lift it that high.
I think you put it on the ground.
There it is. It has holes in the seat, right? So we have
So the next release of Android is called Gingerbread, and it's coming out pretty soon because we put the statue up last week, so it has to come out pretty soon. And I can't talk in detail about what's going to be in Gingerbread, but I will give you the rough information on what we're working on. So the thing that we care about probably more than anything else is performance, performance, performance. Every release of Android has to be faster, and the reason we care about performance so much is one word: games. People really like to play games on their phones. And all the game developers are saying, faster, 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 faster. Of course, as soon as we make it faster, they make the game bigger and slower. So, you never win. As a result, the other thing is that, here's the Samsung Galaxy Tab, and there are many other Android devices coming that are going to be bigger than this, including the Google TV. So we're making some improvements to the software to make it, easier to work with a lot of different sizes. There's a whole speech in the Android track this afternoon about different Android form factors. We're putting some stuff in the framework to make it easier for programmers. And this isn't a Google thing, but there's some community projects going underway to make Python and Ruby and other languages available. But that's only half of it. The other area where we're really doing a lot of work is the Android market. And we want the Android market to be on the web. Right now you can only see it from a phone. So we really want the Android market to be available in a browser. We want it to be a lot bigger. We want more apps and we want more countries. And we want you to go and write more apps. Please do it. And we want to make it easier to handle the money. We want to make it easier to search, easier to buy, easier to track. Stand by. I think there's going to be some very interesting announcements in the immediate future on the Android market. So I'm done now. I want to close with why I picked Android. Occasionally, I am criticized because they say, well, you're always saying good things about Android because you're such a Google fanboy. And that's actually the reverse of the truth. I fell in love with Android 2 years ago, and I joined Google so I could work on Android. So here's why I like Android myself. First of all, I think that open source software is better software. I believe that 100%. I don't think it's controversial anymore. This is open source software, and it's better software. Secondly, the market is not have a policeman. Well, we have a policeman. We don't have a guard at the gate. So anybody can put anything in the market. If it's illegal, we'll take it down again, but you can put anything in. It's accessible. You don't have to learn any new languages. Almost everybody already knows, either Java or C#. You can be a developer in 15 minutes. The Android API is really nice. It's not like the big enterprise APIs where you have factory methods and lots of abstractions. The intents and activities and services are really well designed. They're slick, they're easy, they're beautiful, they're nice to work with, and maybe most important, nothing is hidden. Anything the phone can do is accessible via the API. And the reason for that is we trust the market. If people do something with the phone that is stupid, something in an application that is stupid or dangerous, the word will get around very quickly and people won't buy it. The market is much smarter than Google. Wherever you work, most of the smart people are somewhere else. So the whole idea of Android is to open it up, make it free, make it open source, unleash the full power of the phone, and trust the people to do smart stuff with it. So thank you very much, and I hope you come to some more of the Android talks this afternoon. Thank you for coming out.